Okay. This lab is on sound and measuring the speed of sound in air using tuning forks and temperature. So based on temperature, we're dealing with the kinetic theory of gases that says that the average kinetic energy is equal to 1/2 the mass of an atom times the root mean squared velocity squared. The root mean squared velocity squared is going to be the square of the average speed in the x direction, the average speed in the y direction squared, the average speed in the z direction squared. So you're just a molecule bouncing around in a box. And then we have our old friend, the Boltzmann's constant, which is 1.38 times 10 to the minus 23 joules per Kelvin. And so we see there's a direct relationship between speed squared and temperature in Kelvin. So if we do a little bit of algebra, the root mean squared velocity would be the square root of 3 times the Boltzmann's constant times the temperature over the mass of one atom. If we multiply top and bottom by Avogadro's number, it's 3 times the universal gas constant times the temperature in Kelvin over the molecular mass. The only thing is, air is not one thing. It's a mixture. So we're about 79% molecular nitrogen, 20% molecular oxygen, and 1% everything else like pollen, pollutants, CO2, water vapor. So they had to do an approximation to get a back of the page number. And so it's this weird number of 20.1 meters per second over reciprocal Kelvin. I know it's a crazy unit, but it makes everything correct, times the square root of the temperature measured in Kelvin. And when we do all that, for room temperature, it's about 343 meters per second.